Hello students, welcome once again to another section, and we are to prove that if x, y and z are non-zero real number with x plus y plus z equal to 0, then so let's solve this. Now if we have x plus y plus z being equal to 0, then in this case we can, now if you look at the denominators, in this case we have x squared plus y squared plus z squared, then z squared plus s squared. So what we can do is that we have to find x squared, y squared, then in the form of their squares. So what we can do is that we are going to find so we have, let's make x the subject, and then z, then y the subject. So we are making each of the variables the subject over here. So we have x plus 1 be equal to minus z. So make z the subject, then we can have y plus z being equal to negative x. Then also we can have x plus z being equal to negative 1. Now, so let's call this 1, let's call this 2, and let's call this 3, right? So in the next one, since we have x squared, y squared, so since we have y squared, x squared, y squared, they are squares. So that's what we are going to do. We are going to square both sides for each equation. So for each equation, we are going to square both sides. So we have x plus y here, and what we are doing here is square, then being equal to negative z here, then we square that. Then we have y plus z here, so square that. Then we have negative x here squared, then x plus z here squared being equal to negative y here squared. And this, now when we square here, we are going to get x squared plus y squared. Now we are going to get plus 2xy, but I'm sending it to the other side, so it's going to be z squared, then minus, it was plus, so it's going to be minus 2xy here. So in this case too, we're going to get y squared plus z squared, but we are going to get 2yz, so I'm sending it to the other side, so we're going to get s squared here, then minus 2yz. Then here also we do the same thing here, so we have s squared, z squared, then we have y squared, then we can have negative xz, 2x, then z, right? So this is what we have. Now what we are going to do is that we have x squared, y squared, so we can substitute, we have it here, so we can substitute this into that, then we substitute this into that, then also to the other side. So we have x squared plus y squared being z squared minus 2xy, then divided by, now we have x plus y. X plus y is just we said x plus y is negative z, so we just substitute that. Then we have y plus the next one, y squared plus z squared, which is just s squared minus 2yz, then being divided by y plus z, which is just negative x. So we do for each one of them, so let me quickly do that. So we have the next one to be y squared minus 2xz divided by so with negative y here will be equal to just our z cube over y z, then plus y cube over zx, then we have z cube divided by xy. All right, so xy. All right, so let's do it. So from here, what we are going to do is that let's simplify this. So simplifying this, we are just going to get z here, so negative z, then positive 2xy over divided by z, then we have negative x here, so we are just simplifying that. So it's going to be z squared divided by z, which will be negative z, then this will change to positive, so we'll do for each one of them. So we have 2yz being equal to x here, sorry, then plus we have so negative y here plus 2xz divided by y here, then being equal to just z cube q cube yz plus y cube here divided by sz plus z cube over sy. Remember it's x, sorry, yeah. So sorry for the space. Then let's continue here. So let's continue here. Now you realize that in each case we have negative z, negative x, negative y. So we can factorize it out as, let's say, s plus y plus z here, right? So what we are left with this, that, and also that. So we can factorize 2 out, then we can have xy divided by z, then we have yz divided by x, then also sz divided by y being equal to s cube divided by yz plus y cube divided by xz plus z cube divided by xy. All right, so this is what we have. All right, so this is what we have. Now from in the question where we said that x plus y plus z is equal to 0, so we're going to apply it here. Remember, this is s cube, sorry for that. So let's apply it here. So we said that if x plus y plus z is equal to 0, then we have over here. So if that is the case, which means that the whole of this goes to 0, right? So you are left with this, right? So we have 2 over here. Now solving this, we have the LCM as z, x, and y, right? So we are just going to have s squared y squared, then y squared z squared, then also s squared z squared being equal to s cube over yz plus y cube over zx, then z cube over xy, right? So that's what we are going to have now. All right, so then also we can simplify this also. So we can simplify this, so we can have LCM as syz, so that we can have all right, so we have yz. So yz here, we are just going to left with x. So we have x to the power 4, then we have y to the power 4, then also z to the power 4. Then this is just equal to the whole of that y squared z squared plus s squared z squared being divided by z, x, and then y. So this is what we have. What we are going to do is that we are going to cross multiply, right? So in cross multiplying, you realize that when this goes up there and this goes up there, this will just cancel that, right? So you are only left with the numerators. So with the numerators, we have s squared y squared plus y squared z squared plus s squared z squared here, right, being equal to s to the power 4 plus y to the power 4 plus z to the power 4. And basically, therefore, our x power 4, y to the power 4 plus z to the power 4 is just equal to 2. Then we have s squared y squared plus y squared z squared plus s squared and z squared, right? So this is what we have. So thank you very much for joining me in this section. If this is your first time on this channel, please subscribe and also hit the notification bell, and also leave a comment in the comment section, and also I'll see you in another section.